Hello friend, in this video I will discuss equation of motion with the help of integral calculus. In previous videos in class 9th I have discussed the same equation of motion with the help of graphical and algebraic methods. So in this video the equation of motion is done with the help of definite integral. Okay. So suppose that a particle from point A to B is moving, okay, on a straight line. Initially the speed of particle is u, speed not velocity, okay, and after time t the velocity of particle become v. So initial condition initial condition when time equal to 0, then velocity is u. At time equal to t the velocity becomes v. At this journey let's assume that the displacement of the particle is s and acceleration is a. Okay, so in these three equations we have applied, first we have to apply the definition of acceleration. In second equation of motion we have to find displacement, so we'll use the formula v equal to ds by dt. Okay, in third equation of motion these two basic formulae must be used in third equation motion. That means we can use here v equal to ds by dt and a equal to dv by dt. For proving first equation of motion we have to use this formula. That means if we cross multiply, that means dv equal to a dt. Now integrating this result from initial to final condition. So dv integrated from u to v, because initial velocity u to final is v, dv, and a dt from 0 to t. Okay, if any term which containing constant term will become integration v only. If we apply here formula x to the power n dx, okay, when n equal to what, n equal to 0, then this term become x to the power 0 dx, and this is nothing but x to the power 0 plus 1 upon 0 plus 1 equal to x to the power 1 upon 1 x. That means in case of x to the power 0 the integral becomes simply 1 dx. Okay, in case the integration of that term will become only v. Okay, if you want to integrate with respect to v, if you want to integrate with respect to x, the integration is simply x. So with this mathematical formula the integration of dv becomes what, it is nothing but v only. Okay, and lower limit, upper limit. Similarly a integration of dt becomes t only from 0 to t. Okay, now putting this upper to lower limit with taking minus sign, that means first we have to write v and then u. Similarly a t minus 0. Okay, so v minus u equal to 80, that means v equal to u plus 80. This is the first equation of motion. Now come to second equation of motion. We have to work same ways. Okay, so we have to find here displacement of the object. So cross multiply this term, ds equal to v dt. Okay, now putting the value of v from equation first, so it will become ds equal to u plus 18 and this is dt. Okay, now we can write in this way. We can split these two terms with respect to this variable. Okay, u dt we can write here and a t dt. Now integrating from initial to final. So at initial, displacement is 0. At time t, displacement becomes s. Okay. So initial condition is 0, final condition is s. Initial condition is 0, final is t. Initially the time was 0, at time t the time is t. Okay. So this is s minus 0 similarly, and this is what u t from 0 to t. And integration of a is constant, and integration of t equal to what? T 1 plus 1, because the power is 1. The same formula we have applied here, that is integration x to the power n dx equal to what? X to the power n plus 1 upon n plus 1. Okay, so it will become 1 plus 1 upon 1 plus 1 from 0 to t. This will become what? S equal to u t minus 0 plus a t square upon 2 from 0 to t. S equal to ut plus half a t square. So this is the second equation of motion. Now if you want to prove third equation of motion, then we have to merge this. Third equation of motion will be proved with the help of these two basic formulae. Okay, so if you want to write acceleration, it is equal to dv by dt. Okay, you can write dv by 1 into 1 by dt. Okay, and after that 1 can be replaced with if you multiply and divide by ds into ds by dt. So a equal to dv by ds, and ds by dt equal to what? V. So we can write here v. Now if you multiply a into ds, and this is v dv. Now integrating from initial to final position, that means a from 0 to s ds, and v from u to v dv. Okay, integration of ds is simply s. Okay, so it is from 0 to s. Integration of v is similarly v square by 2. Okay, here t square by 2, and this is v square by 2 from u to v, and this is a s minus 0, and this is what? V square by 2 once time upper limit and lower limit. At the place of v we can put v equal to u, then it will become v u square by 2. After taking common, v square minus u square equal to 2as, and we can write v square equal to u square plus 2as. So this is the third equation of motion. We can prove simply with the help of these two formulae, and then after putting and solving we can obtain the third equation of motion. So this is all about in this video. Thanks for watching. Thank you so much.